Hi, my name is Clayton Christensen, and I'm going to be talking about dependent sources in circuits. Dependent source is a lot simpler than it might seem. Normally, in a circuit, when you're doing analysis, every source has a constant value. So, for example, on the left-hand side of this circuit, you have 5.3 volts is the voltage on the left-hand side, whereas on the right-hand side, you have a dependent current source. Now, a dependent current source, all it is instead of a constant, you have an equation. And that equation is almost always some sort of manipulation of some other value somewhere in the circuit. So in this case, the current going up and down on the right hand, going from the bottom to top on the right-hand side is 2 times the current from left to right across the 6-ohm resistor, right? And signs matter. So if the current is on the 6-ohm resistor is actually going left, then you know that I is negative, whatever that magnitude of the current is. And then that means that your current on the right-hand side would be 2 times negative I, so it would actually be going down. So signs matter, directions matter, but again, it's just an equation. So that actually means that your circuit analysis doesn't change. All you have to do is have one extra equation to your system and include it when you solve, and it takes care of the dependent source. So let's go ahead and you would pick whatever circuit analysis method works / you like the best. I personally prefer node voltage. I try to use it as often as I can. So in this case, I have V1 and V2 here, which is super, super useful. So here I have a little spotlight so I can show easier. All right. Oops. All right. So in this case, I start with V1 and V2, and I write my initial equations. So I'm assuming you're familiar with node voltage analysis. So this would be equation from this node right here, and this would be the equation at this node. And notice here, so in this case, so for the second equation here, I'm measuring the current from V2 to V1 here, I'm measuring the current from V2 to ground here, and then I want to know this current. So in node voltage, we measure outgoing current as positive. So this 2I is supposedly an ingoing current. So I'm adding the negative of it. So I'm adding negative 2I. And notice all I did was substitute the equation for the source in for the value of the source. That's all I did. And so those are your standard 2 node voltage equations. So then all you have to do is, you see you have V1, V2, and I. You have 3 equations. Sorry, 3 variables and 2 equations. 3 unknowns, 2 equations. So you need a third equation. Luckily, we know how we can solve for I. I is just V1 minus V2 divided by 6, right? The voltage difference across the 6-ohm resistor over the resistance itself. Ohm's law, V over R is I. So now you have your 3 equations. So it's a simple process of using whatever sort of system solving tools you enjoy the most. I use my calculator. So I did that earlier. So that means that your voltage 1 is 2.182 volts, and your voltage 2 there is 1.871 volts. And once you know the voltage at every node, right, you know the voltage drops everywhere, and Ohm's law gives you the power now to find anything you want in the circuit. You could find the currents here. You could find anything, right? Now you know the value of this dependent source, because V1, you know it's the difference between these two, which is positive, divided by 6. So you know at least that the current is going this way. So anyway, it's as simple as that.